name's Erik Johnson. I'm just to let you know in advance, in case you can't already tell, I'm fighting a cold right now, so hopefully my voice holds out. So, pardon me. I've been involved with the SaltStack project for over 5 years now. I've been employed as a full-time developer since June of 2013, and I typically work on some of the deep dark things that in the internals of Salt, like the file server and the reactor, things like that. So just as a little bit of a background on who I am. This is my lame joke. I have to have at least one in every talk. Funny thing is, I made this slide not knowing that there's actually is a Holiday Inn Express right next door. So we have a number of important changes that are specific to 2017.7, and when I talk about how Salt's support for Docker works, it's going to be in the context of 2017.7 and later. So later on when I show when I describe how the internals of some of the Docker states work, those explanations will be specific to 2017.7. Just FYI. So one of the important things for 2017.7 is that the original community submitted state and execution module. They're no longer present in the code base. They've been removed. They're now in a repo that we have called SaltConf if you ever want to take a look at them. But the replacements, the replacement modules, which were called Docker NG, now just are named Docker. But we do have aliases that allow the old syntax to be used. No real timetable on when those will be removed right now, but there should be plenty of time if you want to update SLS files to change everything from Docker NG to just Docker, at least for execution module usage. The states, we've actually broken those up because when the state module was written, it just handled containers, and then images and volumes and networks were added later. And that kind of put Docker management out of sync with how we sort of normally handle things. A lot of the not only Postgres but MySQL and a few other things that we manage with Salt, where you have a bunch of distinct types of things. Each of those types of things has their own state module. So now in 2017.7, the containers, networks, images, volumes, those all have their own state modules. And again, the old usage still works. So you may see a warning, but if you upgrade from 2016.11 to 2017.7, your Docker states will not just start throwing errors because you're using the wrong names. We've taken great precaution to make sure that the old syntax still works. One of the other things that's been improved in 2017.7 is argument handling. So there's a number of different things that you can configure about each container. And in the past, the way that the Docker NG state state module was originally written, it was not I would say not the best approach, in that for every argument, every configurable argument that you could specify, we had there was some sort of logic to determine or to compare the existing container against that input, and so what that meant is that we were always playing catch up. And so at the time Docker NG was written, as you can see, there are 31 configurable options. That's more than doubled in a matter of 2 years. So clearly that was not something that could sustain itself. We couldn't just keep playing catch up. So as of 2017.7, now basically as soon as an argument is supported in the Python bindings for Docker, you can use it immediately, and I'll go into more detail on how that all works in a few slides from now. The Docker container running state, now I sort of alluded to this in the previous slide. It handles the comparison between your input and the running container in a much more reliable way. That this is something again that I'll go into depth in a little bit. I will say that there are a few arguments, some of the OOM arguments, and I forget if there are any other ones, but essentially, the way that Docker Pi passes those, it passes them as null values, even though the proper value should be like an empty list or dictionary, and so that messes with comparisons. And so there were a couple sort of hiccups in comparison for new containers. Those we think are more or less resolved for 2017.7.2. We haven't had any further reports when it comes to that. I think also authentication. The Docker NG prior to 2017.7 was not handling, or it was attempting authentication when it really didn't need to, and so the authentication support has been streamlined so that you only ever have to set it up once per minion. So the most important thing is to get started, obviously, in addition to Salt, is that you need Docker Pi. And so I've included some instructions here. You can either install it using pip or using Salt. There's actually two modules. I'm not sure why. I think, so Docker Pi 2.0 is a radical redesign. A lot of things were changed under the hood. And so I don't know if that's the reason that they decided to keep the old one available, but if you look on PyPI, you'll see that there's a Docker and a Docker-Pi. Docker-Pi is the legacy module, and in most cases you shouldn't be using it because it's not going to receive any updates. So if there are new API updates that require that add features that thus need add new arguments that you can use to configure containers, those will not go into the legacy module at all. So there's a couple exceptions. If you're using a 2016.11.3 or older than 2016.11.3, the code Salt itself does not support referencing the new the Docker. The new version of Docker Pi, the Docker Pi 2.0, because of some of the naming of the classes that are used for instantiating a client instance. So if you're using, bottom line is if you're using 2017.7, you should be able to use the newer Docker Pi. The only exception being that if you're using the Docker events engine. That had a similar that was overlooked when I made the fixes to the state and execution module. The same issue with it not referencing the correct class name existed in 2017.7.2, and that's fixed and will be in 2017.7.3. But in most cases, I think you should be able to. You should be fine with the newer, actively developed version of Docker Pi. So once you've gotten the bindings installed, the next thing you want to do is configure authentication. Now, one of the things about Docker Pi that I did not know when I wrote the Docker NG module a couple years ago is that if the config.json, that's the file where your where authentication is configured for the Docker CLI client. If that file is present, the Docker Pi will actually use that for authentication. So, one way of configuring authentication is if you have logged in on the CLI and you can save that config.json, you can You can deploy that with a file.manage, and you don't even have to keep your authentication in Pillar. If you don't want to, or if you don't want to deploy your config.json, there's a link here that links directly to our docs and authentication. It's pretty detailed, and there's several steps on exactly what to configure in Pillar that didn't want to really take up too much time going into here. So if you want to view the docs, by the way, the slides for this are, since this is a Google Slides presentation, it's actually a link. So whereas most of the slides that you would go into the conference app to view will have like a PowerPoint or keynote presentation or whatever, my file there will just be a Word document with a link that'll take you to these slides. So that you'll be able to page through these slides and click on all the links. You don't have to memorize them or write them down. So if you are configuring authentication using Pillar, you can then use there's a function called docker.login, and that is if you're using 2016.11, you would be docker ng.login. Obviously, there is a login function in the legacy module, but it doesn't do the same thing. So it's important to keep that in mind if you're not yet on 2017.7. And so this docker.login will use the Docker CLI, the Docker login CLI command, and it does this because Docker Pi itself does not have the means to actually write to the config.json. It can read it, but it doesn't have anything built into it to edit your authentication. And so as long as you have that config.json present, then that's the only time you ever have to worry about authentication. And from then on, anytime you need to push any images, it'll just work. Here's an example of the Docker container.running state, formerly Docker ng.running. So you can see that you have your image here with the binds. You notice that some of these are absolute paths, and some of these aren't. And the way that Docker handles non-absolute paths when you're setting up, when you're mounting either volumes or local directories, is it first checks to see if there is a volume, a Docker volume by that name, and if there is, it uses it. If there's not, then it will check for a local directory. It's a directory relative to the, I believe, relative to the home directory of the user running Docker, and then it'll check for that. If that doesn't exist, it will create it and mount it. So it's not something where you'll get an error message. So if so it's important if you're using volumes to make sure that you get your that you spelled it properly, because it won't always be. It's not, like I said, you're not going to get an error message to tell you that you've done something like that wrong. And the rest of this should be pretty self-explanatory. The documentation for this state has tons of examples and goes in detail about what all the arguments are and what they mean, because some of them don't make as much sense. These are the actual argument names that we pass to Docker Pi. So some of them don't necessarily always seem like they describe what they are. So the Docker container.running documentation has a thorough explanation for each of the arguments. So looking at the previous slide, let's go back for a second. You notice that these arguments they look a lot like what you would see if you were using Docker on the CLI, and that's a conscious choice. That's what we've tried to emulate the CLI syntax as closely as possible. And so when you have items that you can specify more than once, we typically just will accept a list of arguments for that particular value. And so we carry on that same CLI usage from the execution module to the states as well in the SLS files. And now the CLI format is much different from what the Docker API expects. So the way that we handle this is by translating that input into the format that the Docker engine is expecting. So this is how we handle. This is also how we handle new arguments that are added that we don't have any specific translation logic for, because if there is no translation logic for a given argument name, we just assume that you know what you're doing and pass it through. So if a new argument is added and we don't have anything, we won't be able to support the CLI usage, obviously, but what you would be able to do would be to look at the API docs, and you'd be able to tell the format that they want and write YAML to match that data structure. So I'll have an example of that shortly. So after hearing me say that we're translating your input into a different format, I anticipate the first question is, what happens when we don't translate it properly? And the way that we can work around that is by using the skip translate argument. This is also new to 2017.7. When an argument is having its translation logic skipped, then that allows you to just use the Docker Engine API data structure, format for that argument, and that will allow you to work around any problems with our translation logic, or it'll allow you to, like I said, to handle those new arguments. And then if you are using like newly added arguments and we haven't had time to add them yet, it is probably a good idea to tell it to skip the translation, because once you upgrade Salt and we do add some sort of translation logic for that argument, then suddenly the API version of that argument will stop working, because it'll prefer the translation, and that will break your SLS file. So it might be a good idea to skip the translation just until you have upgraded Salt to a version that where we do properly translate the input for that newly added argument. So I've worked up a little example of how you might put this into practice. So take, for instance, this, we're going back to our example from earlier, and just imagine that the U limits were not being translated properly, and it was causing your state to fail. The way you could work around that would be by adding this skip translate. Okay, go away. Okay, you'd be able to add that little skip translate thing at the bottom, and you would pass the U limits in the format that the engine API expects. And so you can see here the U limits should be a list of resource limits. This is a list of dictionaries in the format name, the name of the U limit, followed by the soft and hard limit values. So as we see in our example, this here is a list of dictionaries. It's a list of dictionaries with only one dictionary in it. But this would be how one way that you would be able to work around any problems with our input translation logic. So the reason why we're actually translating the input is, again, we'd rather people use the CLI usages that they're familiar with. Not everybody wants to learn the entire API to be able to write states. Sometimes people just want to configure a container. And for those who are really into the API and don't want to use any of our input translation, you can actually set that skip translate to true, and it'll bypass all of that. And if you do that, then it expects all arguments to be passed in the API format. So the comparison logic in 2017.7 is pretty radically different from in previous versions. In previous versions, like I said, we would have to have some logic to compare the input that was passed to the value of in the currently running container, and that like I said forced us to continue to continually play catch up. And so what we do now is we actually will create a temporary container using the arguments that you pass in, and we keep that container stopped. We never start it, or we don't start it right away at least. And so now we have two containers, and we compare both the config and host config against each other and find out what values are different, and if we do find differences, we know that the container configuration has changed, and then the container needs to be replaced. And so we actually handle that comparison. There's actually a remote execution function in the Docker execution module called compare container that handles that. It's available to be used if anybody wants to use it, but it's primarily just to be used in the Docker container.running state. And if we don't find any differences, we just remove that temporary container without ever having started it. And if there are differences, we will stop and remove the old container, and then rename the new one and start it up, and it'll take the place of the old one. So this is a much more workable solution going forward. So it'll allow Salt to grow alongside Docker and be able to deal with any new arguments without having people wait for a new version of Salt to be able to utilize them. Image management. There's two states for image management. One will make sure that the Docker.present or Docker image.present will make sure that the image is present, and then there's a Docker image.absent to make sure that the image is not pulled locally. The Docker image.present can actually handle images in 4 different ways. It can download from a registry. You can build it from a URL just like you would do it with the Docker build on the CLI, and you can do the equivalent of Docker load with an exported container, and then also by running SLS files, running states on top of a base image. And so the Docker image.present will only actually proceed if the image actually does not exist. If the image exists, it'll just say that the image exists, and it won't even try to rebuild it. You would use the force argument to make it a rebuild. So that's in that way it differs from Docker build, whereas Docker build, if you just type Docker build, it'll build from whatever layer it doesn't it'll build from whatever layer it decides it doesn't have, and so Docker build on the CLI will detect changes, but if you're building from a Docker file using salt states, it's not going to be able to it doesn't just automatically run Docker build every time. So here's an example of the SLS for making sure that an image is pulled from a registry. As I mentioned just a minute ago, the image will not be pulled if it's already present, and it's important to note that if you're using Docker container.running, it'll actually pull the image if it doesn't exist. So you don't technically need to use this if you're just getting the image from the registry. The only exception would be if you want to use force to pull it to make sure that you're pulling a new copy of the image every time. But if you don't want that, and then there's no need to use this state to ensure that you have the image, because the Docker container.running will do that for you. Building from a Docker file uses the build argument. So you can use a local path on the minion, or you can use a URL just like the Docker build CLI command. The one exception with URLs is that we don't at this time support using salt URLs. That's something that should be pretty easy to add, but we would have to download, recursively the entire directory that you pass it to be used as the context for the build. So I mean, that's something that we might see in a future version, but as of right now, building from a Docker file is not supported with a salt URL. And then there's a Docker file argument if you want to use a file name, if your Docker file is named something other than Docker file. And this is useful if you have a bunch of different images that you all want to build from the same context files. To load an image from an exported image, just use the load argument. It's pretty self-explanatory. I'm not 100% sure that it does have to be an uncompressed tar archive. This may be incorrect. I don't believe I've tested that, so that would be something I would have to double check on. But this will load any image that has been exported using Docker save. And because it's just a single file, and we don't, it can come from a salt URL, not unlike with the build. Using SLS files to build, you just use the SLS argument, and that will run these state files in succession, WebApp1 first, followed by WebApp2, over the CentOS base image, and it'll pull using this SaltEnv argument, tells that the SLS argument which environment from which to pull these SLS files. Base is the default. You don't need to use it if you are pulling from base. The only time you would technically need this is if you're pulling from a different file server environment. Volumes. Again, volumes are very simple. There's not a lot to the SLS for that. There's just using Docker volume.present will create a volume using the default driver. And if you want to use a different driver, there's the driver and driver opts arguments for that, and those will allow you to configure something other than the default driver. One thing to note is that if the volume exists by the same name, we won't try to do anything with the volume. In fact, that's not exactly, you don't want to just remove a volume if something changes. And we don't ever do that. But we also don't notify you if the configuration that you have, let's say you change the driver, but the image remains the same. We'll still report that the image is present, but we could probably improve how we do that and report that the image is present but doesn't match the same. It doesn't have the same driver or something like that. Those are some improvements that we could make. So that's something to keep an eye out for. Is if you for some reason decide to use a different driver, then you do have to actually delete the volume first if you want Salt to actually create one with that driver. For network management, this is a state that is getting a lot of upgrades for the upcoming feature release. As of right now, you can only pass the driver and driver options, and then you tell the Salt which containers belong to the network via an argument called containers. Actually, in the next feature release, you'll actually be able to configure network membership on a Docker container.running state. So this sort of usage here will still be supported, but it won't be recommended moving forward. And actually, I put the wrong version here in this slide. It's actually instead of 2017.7.3, it's coming in the Oxygen feature release. So again, not a whole lot to the SLS for that. There'll be a lot more options for network configuration beginning in the next feature release. So keep an eye out for that in the release notes and in the documentation. So here's our configuration example using all 4 states. And you can see we have some requisites set up here. This is making sure that we have we have the actual image that we need before we try to run the Docker container.running state, and make sure that we have the volume that we've configured here before we run that, and then that we make sure that the container is created before the network is. And that's probably, like I said, that's not the best way of going about it, obviously, because you would like to have your container configured you would like to have networking configured before the container starts. But because of the way that the networking support installed, the Docker networking support installed is constructed with container management or container membership in the network configured on the network state, there's a bit of a chicken and egg issue here. Obviously, you can't run the Docker network state right now without the container already being present. Again, that'll change for Oxygen. You'll actually be able to add some configuration in your Docker container.running state. I'll have a little bit of a preview example of how that would look in a future slide here. But that should be a little bit better approach moving forward, because you won't have to worry about a container not having network immediately when it's started up. Some additional things that you can do with our Docker support is to run commands within the running container. This is just basically a loose wrapper around Docker exec. And so we have a bunch of functions that mimic the CMD module. So we have docker.run, which is not the same thing as Docker run, obviously. It's Docker run is like cmd.run, only in a Docker container. And we have docker.run all, etc. These are all exactly like their CMD module counterparts. Some further documentation on running commands. There's a link there in the documentation, and we also have a bunch of equivalents to most of the Docker CLI commands. Maybe not all. I haven't checked recently. There may be some new ones that we don't yet have a function for. But you can within Docker remove images, remove containers, etc. Using remote execution functions. And this here is at the bottom is a link to the execution module where you can see all the different functions and what they do. The create function is the function that we use to actually create the container, and that has again extensive documentation for every single all 63 or 64, however many arguments that you can pass in. There's examples for each of them. It's pretty extensive, and it's a good reference if you need to know what format to pass those values in if you're doing anything with the Docker execution module. Although we find most people prefer to use states for that. Now there's a number of issues with docker.present that will be fixed for the Oxygen release. One of the things is that the Docker network.present state is not entirely idempotent right now, so it'll try to attach to the container it'll try to attach all the configured containers to the network every time, and so that Actually, I'm sorry, that's incorrect. Not every time. If a container is not running, it is not reported as being a member of that network. And so even though the container is technically a member of that network, if it's stopped at the time you run the Docker network.present state right now, it'll try to reconnect. It'll try to add it, and which it won't cause an error, but it'll report that it tried to do something every time. Starting with the Oxygen release, we'll actually detect if the container is actually stopped and not attempt to connect it. The Docker network.present state also, as of 2017.7, if you change anything about currently the only things you can configure are the driver and the driver options. If you try to change, for instance, the driver options, that won't cause the network to be replaced. It's similar in that respect to the Docker image and Docker volume states, in which it's only checking to see if a network by that name exists presently. So if you want to change any of the configuration with the network, you're not really it's not actually going to replace it right now, which is not good, but will be resolved for the next feature release. And another of the major pain points that we've got reported, a lot of reports on, is that the 2017.7 and previous release cycles can handle managing more complex networks, so ones with that custom subnet and IP range, things like that. That's all going to be supported fully in the same way that all of the arguments are supported now. For container creation, network creation will also all of the arguments available to configure our networks will also be supported. So the network support will be improved pretty significantly for the Oxygen release, so keep an eye on the documentation and release notes, obviously, for that as well. There'll be config examples of how those arguments should be passed. Some of those fixes are actually already present. Like if you are running from the develop branch right now, you'll be able to configure some of the IP management stuff, like IP range and subnet. But some of the other things, like whether or not the network is restricted to internal connections only, things like that are part of the API, that are supported in the API but not supported currently in Salt, will also be supported for Oxygen. Some other known issues right now that we'll have fixed for Oxygen include the fact that currently, if you noticed in the isolastic examples, when we're working with an image name, we have people pass the image and tag name in the repo :tag notation, and then Salt will try to just parse that out and figure out what the tag which tag is being used. But if in certain cases where people are running their own custom registries, the parsing logic isn't it doesn't work properly for those, just because there's extra colons and slash and extra. I don't think there's extra slashes, but it makes it a lot more difficult to parse. So rather than just trying to constantly play whack-a-mole with issues with parsing, the Oxygen release will add a new tag argument that lets you just pass the tag manually if you desire. If you don't, it'll still try to parse it out of the repo :tag notation, which should work for most people. But for those who for whom that doesn't work, they'll be able to pass the tag separately, and which will take care of that particular annoyance. And again, I mentioned earlier that the Docker container.running state will have network management built into it in the Oxygen release. That'll allow you to configure the networks in the container in your Docker container.running state, such that when the container is replaced, it is replaced with and already connected to the network, and you don't have to worry about rerunning the Docker network.present state. And So that will be just additional functionality. Again, we won't be removing the old way of specifying a container's membership in a network. You'll still be able to do that in the Docker network.present state, but it'll be it's not going to be like the recommended way of doing it, starting with the Oxygen release. And so this is the example that I did before with some of those new features or new fixes in place. You'll see that you could specify the tag manually here. And this is how network configuration would look. You have your network name, and then this would be your list of aliases that you're configuring. You could also use there's the like IP range, subnet, etc. There's several arguments for that. These are all actually these will all be in the docs as well. And for the ones that we can't cover, there's actually a link to the API documentation that'll tell you what those arguments are. So if there's any that we don't cover in the docs, you'll be able to refer to the Docker Pi documentation to figure out what argument name to use. For instance, if you want to specify a static IP address or a different IP range, or set up reserved IP addresses and stuff like that, you'll be able to do all of that. It's important to note that you'll only be able to do that using this new functionality in the Docker container.running state. There's no plans at this time to add that functionality to Docker network.present because we prefer this is just a better way of setting up networking, and we don't plan on adding all this additional argument configuration to the Docker network.present state at this time. So that concludes all of my slides. I don't know if we have time for much of a demo. Looks like we're right up against the end of our time slot here, but I'm happy to answer any questions if anybody has any. So the question was that will we have any support for Docker services? There is no code in develop for this right now, but as long as it can be created via the API, then there's no reason it can't be added. It just doesn't exist in the development branch right now. Yeah, so we actually what we're investigating right now, and I'm not sure if you heard some of the in the general session stuff this morning about the test kitchen stuff we're doing for testing, using the Kitchen Salt project to test salt states. We're actually planning on integrating that and into our Jenkins setup for automated testing, and we would be looking to use Docker Swarm and probably services for that. So that we would be implementing it anyway probably for that purpose. But it doesn't exist right now. It looks like we're planning hopefully early 2018 for the Oxygen release. So it's unclear whether something like that could be added yet at this point. So it may slide to the next feature release. But yeah, there's no reason it can't be added. Yeah. Any other questions? Okay. All right. Thanks, Sam. I hope I was easy enough to understand.